I'm Deja.
And I'm Brandon, and today we're going to teach you about
Cairns' technique for measuring DNA.
November 21st, 1922. He became a British physician and a molecular biologist after studying at Oxford, where he earned his MD. Eliza Hall Institute in Melbourne, Australia, where he worked in virology, and a research institute in Uganda. He also studied at Mill Hill in New York, where
Audioradiography is basically labeling something with radioactive materials and exposing it to X-ray radioactive film to be able to visualize what you're seeing. Emulsion is a mixture that results when one liquid is added to another and is mixed but not dissolved. Semi-conservative. A double-stranded molecule of nucleic acid separates into two single strands, each of which serves as a template. Isotope. Each of two or more forms of the same element that contain equal numbers of protons but different numbers of neutrons in their nuclei. Ultrastructure. A fine structure within a cell that can be seen only with the high magnification obtainable with an electron.
An autoradiograph is an image on an X-ray film or a nuclear emulsion produced by the pattern of decay emissions from a distribution of radioactive substance, in our case, tritiated thymine labeled with tritium H3, with the first radiograph being taken in 1867 to observe uranium nitrate. Cairns was not the first to use an audiograph, but he was among the first to measure DNA and observe replication in depth.
First, the cells must be incubated in radioactive thymidine. This later allows the radioactive thymidine to generate tracks of silver grains in the emulsion. Next, the tritiated thymidine is added into the cell, specifically the chromosome. The cells are lysed, leaving behind only the chromosomes and then placed on the photographic surface. Then, place the photographic surface in the emulsion. Radiation from the tritiated thymidine will turn the ions in silver bromide into metal grains. Basically, the excess silver bromide is washed away. The remaining silver bromide will look like small dots. Once the photographic film is finished, you'll be able to see the chromosomal DNA through an electron microscope.
As you can see, this diagram goes over the steps, which we have already observed, and the basic lab that John Cairns created. It separates the process into three parts: the preparation, main process, and development. This would be a key reference picture when you study for the IB test. In order to investigate replication, Cairns had to insert tritiated thymidine into the tritium H3 because it has a heavier oxygen base and is able to show up on a radioautograph because it's radioactive. If you were to look very closely, you'd see that between every base pair, there's a space. This space is where the tritiated thymine is, and it shows through the radioautograph. Cairns was able to produce these images of DNA through the previously mentioned steps. For my strengths in this project, I took my time trying to understand the content, and I had a lot of fun with the visuals. And for my weaknesses, I didn't go in as in-depth as I like to because of the time limits, and I worked while I was tired.
So for my strengths, I'd like to say that I was able to quickly find information and share it with my partner. However, for my weaknesses, it was hard to decide which information was useful and which wasn't useful. Another weakness was, it was very difficult to operate this site and learn how to use it.
Created using Powtoon.